So good afternoon students, finally NEET exam got completed. I hope everyone did this very well, and firstly I can say about this chemistry paper, particularly from NEET 2026. The paper is really easy to moderate, I can say, and when I compare with 2025 paper, it will be definitely easy paper in all aspects if we compare with the 2025 paper. Okay, particularly if I say about chemistry also, here it is strictly based on NCERT, we can say, and you can solve it without any difficulty in any of the question given here. Okay, so definitely this year we will be seeing very huge increment in the cutoff, but last year we have seen paper was difficult, even cutoff also decreased. Okay, but this year we will be seeing again same like 2024 paper. Okay, right. And one more thing here, I can say I am very happy and I am very satisfied with the thing that I have contributed for the last batches, whoever taken coaching in our NEET World YouTube channel, as well as the offline classes, as well as crash course in both offline and online classes. Okay, so I felt like whatever the things came in this paper, everything is covered in my sessions. Okay, I can assure that. Okay, so now let us go through each and every question in chemistry syllabus, chemistry subject, so that you will get complete clarity from the discussion. So the first question here you can see, 46th question here I can say, and this is paper 12, code 12. For this particular paper the code will be 12. Okay, so now the first question here, that is 46th question, says the conversion of cumene. What is this? Cumene to phenol. So this is one of the very important reaction now, cumene conversion to phenol. So how it takes place? With the help of oxygen, okay, and followed by what happens? You need to treat with water and H place. So this is the most repeated question, I can say. Even I have covered this in our 100 days NEET challenge short videos also. Okay, so now what happens? First peroxide bond formation takes place, that undergoes rearrangement in the presence of water and acidic medium and gives you the final product. That's it now. So the next one here, carboxylic acid conversion to alcohol is there, and alcohol primary conversion to secondary alcohol conversion. So how it can be happening? Yeah, so first you need to remove this water, that is alcohol as a water, dehydration, then you can add water to the alkene product. So first alkene product will be formed here by dehydration. Okay, so to this if we add water in presence of acidic medium, okay, what happens? Markovnikov rule, addition takes place to give a secondary alcohol. That's it now. So C here it will be C, here it will be 4. Okay, so what I told you, A2 B3, A2 B4, yeah. So A2 B4 only, here we have option number 2. Once again check the options. Once again I am saying A2, the next this one C is 4, A2 C4, here no, yeah, only fourth option is your perfect one. Okay, and the next one if you want you can go through the other options also, like phenol is there, benzene is there, conversion to the phenol. So as per the options, if you see, can take benzene, treat this with oleum nothing but H2SO4 plus SO3 mixture, that is what sulfonation takes place. So benzene sulfonic acid is formed first. Okay, benzene sulfonic acid treated with NaOH. What happens? Substitution takes place finally, and treating with acid, like removal of this group takes place and gives you phenol. Okay, that's it. Okay, so this is how you can match them. Very simple questions. The next 47th question here. See, everyone knows who studied hydrocarbon chapter definitely come across this thing. See, they have taken ethane here, C3, C2H6 means ethane. Ethane treated with chlorine in presence of sunlight. What happens? They told monochlorinated product. Free radical substitution gives you ethyl chloride. Ethyl chloride treated with ammonia. So ethyl amine is formed. Ethyl amine treated with NaNO2HCl. Definitely they can answer this. I know, because we have practiced a lot about this. Particularly we have practiced like this. Aniline with NaNO2 NaNO2 HCl at 0 to 5 degrees Celsius, benzene diazonium chloride is formed. That reactions we have practiced, na? Same thing here also. Ethyl diazonium chloride is formed first. Okay. After this, treating with water gives you ethyl alcohol. Ethyl alcohol. Okay. So what is your answer? Finally, second option is your answer. Next. Here in qualitative analysis, yeah, the last minute I have covered qualitative analysis also in the revision part also. Okay. So now what happened here in qualitative analysis, Bi plus 3 is detected as hydroxide. Detected as hydroxide, here they are saying calculate the pH when the following equilibrium exists. So this is the equilibrium existence they are saying. So Ksp for this equilibrium is given like this. So how can you say? Ksp is equals to concentration of ions that we have here the product side. Okay, you can say like this. Okay, let us say S concentration for both of these things. So Ksp will be equals to S into S. So this is S square. This is equals to Ksp value given as 4 into 10 power minus 10. Okay, so now S square is there. I just want S value because for OH minus it should be S. So you can say this as 4 into 10 power minus 10, which I can write as S is equals to 2 into 10 power minus 5. That's it now. Yeah. So we got finally OH minus concentration as 2 into 10 power minus 5. So apply log to that. So S is nothing but OH minus ion, which is equals to 2 into 10 power minus 5. So you can make it as POH by applying minus log of 2 into 10 power minus 5 to this. Yeah. So it will be how much? 5 minus log 2, 5 minus log 2. Log 2 value is mentioned here, no need to worry, 0.3 they have mentioned, it will become 4.7 around. Okay, this is POH. Now what they are asking us? They are asking about calculate the pH. So POH we got now, so pH from that you can calculate pH plus POH is equals to 14. From this I want pH. So 14 minus POH, 14 minus 4.7, this is 9.3. Okay, this is the pH. Finally, you have option as 3 for this particular question. Okay, I hope this discussion is also clear. Guys, if there is any confusion, please let me know in the comment box. We will be discuss them once again. Okay, right. The next question, if you have seen here, so 49th. So if you are not studied this properly, definitely you won't able to answer. But if you go through it properly, then it is easy. You know Gay-Lussac's law. So it is simply based on Gay-Lussac's law, you can say. See, when 1 decimeter cube, or you can just simply take it as 1 volume or 1 liter you can take. CO2 gas is passed over hot coke. It means CO2 you are passing through hot coke, that is carbon. Okay, now what happens? You are going to get CO. Carbon dioxide converts into carbon monoxide. So I can say carbon is acting as a reducing agent here. Okay, so 1 CO2 is converting into 2 CO. Okay, both of them are gases here. You take only gases. Now they are saying, once read the question, hot coke, the volume of gaseous mixture after complete reaction at STP becomes 1.4. Initially it is 1, finally it is becoming 1.4. The composition of gaseous mixture after the reaction, that is at the STP. Okay, they mentioned it as STP, it means temperature, pressure are constant. So in this case, you can relate gaseous number of gaseous reactants and products in terms of their volumes. Like you can see, this is 1, this is 2. So I can say 1 volume of CO2 forming 2 volumes of CO, 2 volumes of CO. Then they have given, initially they have given 1 decimeter cube of CO2. Okay, 1 decimeter cube of CO2 they have given, and finally it is forming 1.4. It means from this 1 decimeter cube I can say some X amount is converting into carbon monoxide. So it is 1 first, little amount is converting into CO now. So how much amount, that is 2x here, it will be 2, so 2x I can write. Okay, up to here it is clear now. So now you can say total volume is how much at the end? 1.4. It means 1 minus x plus 2x is equals to total volume. How much it is? 1.4. So 1 plus x will be now 1.4. From here x will be 0.4. Okay, how much? 1 minus 1.4 is 0.4. Done now. So we got quantity of CO formed here. That is how much? 2x. So 2 into 0.4. So quantity of carbon monoxide or composition of carbon monoxide is 0.8, and composition of carbon dioxide will be 1 minus x, 1 minus 0.4, that is 0.6. That's it. We are done with the question. Now go through the options having like this. Okay, so there is a 0.8 CO, 0.8 CO, 0.6 CO2. So as per that, you can go with option number 3. Okay, right. Let's go with the next question here. 50th question. Again, very simple quantum numbers question. Even an IP student who prepared for board exams can also write this. Even a class 10th student can able to answer this if you are aware of this atomic orbitals, subshells, all these things. Okay, we know these are quantum numbers. I mean principal quantum number given as L, N, and azimuthal quantum number or angular quantum number L, and respect to orbital subshells are mentioned here. See, if L value is 0, we know it is a S subshell, S subshell. Okay, if L value is 1, it can be a P subshell. L value 3, it can be what? D subshell. Okay, see L0 S, 1 P, 2 D, 3 F. Like this you can match. So where do we have? L1 means 2P, 0 means 4 and 0, 4S it can be. Okay, next 5 3, 3 means F now, 5F it should be. So it should be 5F like this. Okay, so it is 3 2, 2 means what? D. So D is 1. Like this you can match based on your understanding. I hope it is clear. Next, again this is also one of the important question that every class teacher might cover. This one, see what they have given. Benzene is mentioned. Benzene treated with chlorine when it is in the presence of AlCl3. So whenever you are saying AlCl3, there it will generate an electrophile. What is the electrophile generated? Cl plus. Now this Cl plus as an electrophile enters onto the ring, because this benzene ring contains pi electrons. Now they can act as a nucleophile. Now what I can say, this electrophilic, aromatic electrophilic substitution takes place. So on each of this position, hydrogen is replaced by chlorine. Therefore what we are going to see, we will be seeing chlorine, chlorine, chlorine on all the carbons, and it retains its aromatic nature. It's a simple aromatic electrophilic substitution reaction. Okay, right now, so how many chlorines we are seeing in this X product? So 6 chlorines. Now what about this one? So here it is mentioned as chlorine in presence of sunlight. So here wherever pi bond is there, you break that pi bond, insert chlorine on both the carbons like this, like this. So it is losing its aromatic nature. Okay, so we can say it is a gamma-oxane product. What is that? Gamma-oxane. So how many chlorines are inserted? 6. So what is your answer here? 6 and 6. That is second option is your perfect for the discussion. Okay, next let us move forward with the 52nd question. Yeah, so again from organic, very simple. Yeah, again if you see NCERT, there will be a direct line related to this. Okay, even in the every class, whoever might be the teacher who is teaching you definitely gives this. Without this, alcohols chapter will not be completed, right? Okay, so now what I am saying, PCl5, we know 2 bonds are weaker axial bonds. So one of the chlorine comes here in the place of OH group, follows SN2 reaction, we will say. So in the place of that axial chlorines, we can place this oxygen, converts into POCl3, and this will be removing hydroxy group, replace that with the chlorine. So propyl chloride is formed. What is our X formed here? POCl3, and HCl gas is liberated here. The next, now treating this with alcoholic KOH under heating condition gives you alkene as a product. So what will be the alkene? This 1,2 elimination takes place to give this alkene. Okay, now to this we are adding HBr in presence of peroxide. So in presence of peroxide means anti-Markovnikov rule now. So Br comes at the terminal. That's it. This is your final answer. Okay, this is the Z and X is POCl3. So what will be your option here given? X is POCl3, POCl3, POCl3. And what about Z? They have mentioned here this is Markovnikov rule product, anti-Markovnikov rule product. Fourth one is your perfect for the discussion. Okay, next, what about this catalyst that we use generally in these processes? See, for ammonia, Haber's process, preparation of ammonia from N2H2, that is what? Haber's process. There we will be using iron as a catalyst. Right now, Then next, polymerization of alkenes, preparation of sulfuric acid, and from SO2, that is contact process, those things we'll study in the P block elements now. So there we'll use V2O5, vanadium pentoxide. Okay. Then next, conversion of ethane to ethanol. What is that? Conversion of ethane to ethanol. So it will be PDCl2. Okay, here it is remaining. That's it. So based on, you can match A3 in two options we have. Next, B1 only this option. Yeah, that's it. Fourth option is your answer for the discussion. Okay, you can verify again. If you have any confusion, please let me know in the comment box. Then next, see, even direct questions, all these things I have discussed in the class itself. So even in the crash course also I have discussed maximum topics. Almost 99% of all these topics were even covered for crash course, that course that we have conducted for last 40 days. I have discussed everything that came in this paper. Okay, so who are watching, even the crash course students, if you are watching this live session, please mention if anything is out of our discussion. Yeah. So next question here, identify the correct statement about ClF3. Yes, ClF3 directly you can say 7 plus 3, 10 by 2, it is 5. 5 means it definitely sp3d with 3 bond pairs, remaining 2 lone pairs will get a T shape. Okay, so it has T shaped geometry with 2 lone pairs on chlorine. That's it. This second statement is perfect for the discussion. Next, here this is related to Nernst equation. Simple again. Calculate the EMF of the cell. So E cell equals to E naught cell minus 0.059 by N log concentration of product by reactant. So here what is happening, H2 is converting into H plus. Right now to balance this I can take 2 H plus. So simply you can write product concentration by reactant, that is H plus ion to the power 2 because stoichiometry is 2, and here H2 is a gas, take PH2 in the denominator like this. That's it. Almost it is done. So now standard electrode potential for hydrogen cell will be 0. Okay, so here E cell becomes minus 0.059 by N. How many electrons are involving? 2 electrons here. So log concentration of H plus ion. H plus ion is 2 into 10 power minus 2 I can write. 2 into 10 power minus 2 to the power 2. So it becomes 4 into 10 power minus 4. Okay, and pressure of H2 is given as 2 atms. Okay, 2 atmospheric pressure. So this will be 2 times. Okay, done. So this will become now 0.059, that is simply I am taking it as 0.06 by 2, that is 0.03 into log 10 power minus 4 means I can write simply as minus 4 because log 10 power some x value is there means it becomes x. Okay, something like this. Log of 10 power x means x we are writing now, here it is minus x means your answer should be minus. Okay, minus x, that's it. So minus 4 minus log 2 means it is given as 0.3 there, so you can take that. Okay, that's it. So it is minus 4 plus log 2. Okay, it is something like log of A into B formula. What you can write? Log A plus log B. So this model we did in the class also. Okay, so how much it will be? 0.03. Here already we have a minus symbol and that I am writing as it is. So 4 minus 0.3 becomes how much? So it will be for 3.7 with a minus symbol we have, you can make it plus. Minus of minus becomes plus. Okay, so upon multiplication you will get a plus value of how much? Here 21, 2, 9, 10, 11. Okay, with 3 decimals 0.111. So where do we have such option? So option number will be perfectly correct for the discussion. That's it. Okay, let's move forward with the next question. See, even if you watch any of my YouTube live session that I have covered on chemical kinetics, I will not skip this. Every time I discuss, I will be covering this question for sure. It's a very basic and important. I tell you one tricky way also in the classes, like what is a rate constant unit generalized formula? K units. Rate constant indicated with symbol K, having units something like this. Concentration to the power 1 minus N time inverse. That's it now. So now look, concentration means molarity only now, mole per liter. What are the units generally will take? Mole per liter. So mole per liter to the power 1 minus n time inverse. So time inverse here it is mentioned as second inverse, no need to worry about this. So you just substitute here. If I put n value, n represents order of a reaction. If n is 0, the units will be mole per liter. So mole per liter per second is a unit for 0 order. So A4, okay, like that if you do for first order it will be second inverse only, okay. For second order it will be like this, and third order remaining thing, that's it. Based on that matching you can match your answer. Okay, next question here we have 57. So again very simple, in the D block elements we have covered this kind of ions, very easy. So titanium plus 2, scandium, titanium, na? So 22, it means 3d2 4s2 electronic configuration, valence electronic configuration. But with plus 2 charge is there means remove these s electrons. Now how many unpaired electrons we have? 2 unpaired electrons in the d orbital. So if number of unpaired electrons are 2, then its magnetic moment value becomes 2.84. Okay, so I told you this trick also. If it is 3 unpaired electrons, your magnetic moment value will be around 3.9. Like that, if it is 4, it will be 4.9. Like that, we have discussed in the class for remembering purpose. Okay, now what is the formula to be used? Root over n into n plus 2 Bohr magnetons. This is the formula to be used. So 2 into 2 plus 2. So 2 plus 2 is 4, 2 is 8. So root 8 will be how much? Root 9 means 3. But root 8 means it is around or nearly equals to 3, that is 2.84. So we have only one option. So go with that. Next, the products X and Y formed in the following reaction sequence. So how can you answer this here? Just look at this, benzene treated with methyl chloride. So what is this? Friedel-Crafts alkylation, no? So what happens? First AlCl3 Cl removed as AlCl4, generation of electrophile takes place like CH3 plus. So this will be attacks over the benzene ring. So the W, the product formed here will be methyl benzene. So this methyl benzene upon nitration, what we are doing, nitric acid and sulfuric acid means it's a nitration. So nitration, what is the electrophile involved here? NO2 plus, nitronium ion. So now that electrophile can be directed either ortho or para position. So what are the two possible products here, X and Y? One is ortho product and para product. But here para product will be formed as major, just remember it like that. Okay. Now how can we, what they are asking, what is a suitable method for separation of these mixtures? So this is para nitrotoluene, orthonitrotoluene can be separated by fractional distillation methods. Okay, they have molecular, boiling points equally, almost near. The next 59th question, if you observe, a bulb is rated as 150 watt. So what do we mean by 150 watt? So 150 watt means joule per second. So for 1 second, this much energy, 150 joules of energy. Okay, now this bulb is rated as 150 watt, converting 8% of its energy into light. So 8% of this energy, okay, converting into light. So how much is 8%? We will calculate this. Okay, if the energy of one photon, see, if this is the light source having this much energy releasing in the form of photons. Okay, so now from that particular 8% energy, how many photons can be comes out with each photon of this much energy? So each photon of this much energy, so I can write like this, E energy of light will be equals to now number of photons into energy of each photon, that's it. So this is how you can understand it. Okay, so now simply I can mention this, energy of one photon is how much? Given 4.42 into 10 power minus 19 joules. Okay, we need to find this n value here. So what is the energy of light mentioned here? So you can simply remove this. Okay, so it becomes 1.5, 1.58, so 8 plus 4, so it will be 12. Okay, so how much? 12 joules per second, that's it. 12 watts you can say, or 12 joules per second you can say. Okay, now try to simplify this. So joules can be removed. This is 4.42. We know 4 3s are 12, but it should be less than that 3. So it means 2. There should be something like 2. So I can write it as 12 by 4.42. 10 power 9. This is the number of photons coming out. Okay, now try to simplify this. It will be around 2 point, as per the options if we go, 2.71 will get 2.71 into 10 power 19. So do not worry about exact value, just look at the options, you can easily get from there. Right now, yeah, let's move forward. In a test tube containing a salt solution, what they are saying, in a test tube containing a salt, few drops of vapors having smell of vinegar, the vapors turned blue litmus to red. So very simple, even in the salt analysis, see, salt analysis, I know definitely there will be one question, minimum of one question from salt analysis. So that's why the last 3 days of my sessions, I have spent just some 15 to 20 minutes for all the batches, I mean crash course batches as well as my long term batches, and I have revised this. Okay, and there I have discussed about this vinegar smell. So vinegar smell, from where it comes, from acetic acid only. Okay, so where do we have acetate ion? So what I am saying, when you add sulfuric acid to the salt solution having acetate ion, that converts into acetic acid. Now what is the smell of acetic acid? That is nothing but here vinegar they mentioned. And they told blue litmus converting into red, definitely, because acetic acid is an acidic substance, converts blue litmus to red. Blue litmus to red, that's it. Based on this, first option your perfect answer for the discussion. Okay, next. What about sulfide ions? Sulfide ions will give you H2S gas, very bad rotinic smell will be observed. Okay, what about carbonate? Carbonate gives you like CO2, brisk effervescence we will say. Okay, that can be confirmed by passing through HCl gas. Okay, at the mouth of the test tube if we put HCl, you will see white dense fumes. That is a story of this carbonate. Next 61. See, 61 says selection of reagent that reduces nitriles to primary amines. Nitriles means R C triple bond N converting into primary amines, R CH2 NH2. Now how can we convert this? Yeah, using reducing agent. And we required specifically strong reducing agents like this. Lithium aluminum hydride is the best reagent. So now what about SnHCl? No, SnHCl stops the reaction after formation of imines. We will see that in the Stephens reduction right now. So it is not the suitable one. And you can also use metal hydrogenation, nickel H2. Yes, metal hydrogenation also extensively reduces this given nitriles to amines. Okay. And the next, this is called Mandius reaction. What is this? NaHg C2H5OH is called Mandius reaction. That is also suitable here. Bromine in aqueous NaOH. What is this? Hoffman bromamide degradation method. So Hoffman bromamide degradation will be used for conversion of amides, not amines, not nitriles, but amides to primary amines. Amides to primary amines. This is use of E, but here it is given cyanide, so E is not at all correct. Okay, B is not at all correct. So just go with the known options. See, A definitely correct. Okay, and I told you C, and then remaining D. Only AC having only option 2, so go with that option. Okay, next. Yeah, again this question is also easy from P block. We know if B is like E is B means we have BCl3. Yeah, it exists as a monomer, but when it comes to aluminium halides, they will be like dimers, Al2Cl6. It's a dimeric form we have studied. Okay, this is perfectly correct statement. They are asking about incorrect. Carbon has ability to form p-pi multiple bonds. Perfectly correct, no? Right. Next, incorrect statement they want. Oxygen exhibit only -2 oxidation state. No, oxygen can be in -2 oxidation state for most of the compounds, but it can also be with -1 oxidation state in hydrogen peroxide. What is the oxidation state in the peroxy bonds? It will be -1. And when it comes to superoxides like potassium superoxide I am writing. So each oxygen will be here with -half oxidation state. When it comes to OF2 molecule, here oxygen is in +2 oxidation state also. So we have different possible oxidation state for oxygen. It is not -2 only. So it means what you can say, the incorrect option here will be 62 third option. Okay, so this is about the story of the NEET 2026 paper. When it comes to fourth option, you can verify it, the order of catenation property of group 14. So down the group, what happens to catenation property? Catenation property decreases. Okay, so carbon has a self linkage property now, that is what we call it as a catenation property, right? So carbon shows maximum, and as we go down the group it decreases. Okay, so the incorrect, most suitable answer for this particular discussion is option number 3. Okay, right. The next one here, although +3 oxidation state is common in lanthanides, cerium still shows +4 oxidation state. Why? See, again every year we will be seeing one question either in the JEE mains or NEET or any such exams like EPSET. There is a question related to cerium. Why? Because cerium has very good applications in analytical chemistry also. Okay, now here cerium from +4 oxidation state, see, cerium shows +4 oxidation state still, because in +4 oxidation state cerium having F0 electronic configuration. So with no electrons in the f orbital, like having a nearest noble gas configuration. That's why it can be showing +4 oxidation state. After losing one electron from Fe cerium +3 to +4, means F1 to F0 conversion, it acquires F0 electronic configuration. That will be the thing you need to consider here. Okay, yeah, see they are saying F14 electronic configuration. No, it is the nearest its nearest inert gas is radon. No, it's not radon. Okay, next, that's it. This is the most suitable answer for the 63 question, option number 4. Next, 65. Yeah, every time when we cover the purification techniques, the practical approach, qualitative and quantitative aspect of organic compounds, we will be discussing about Lissagne's test. What is the use of Lissagne's test? We can convert that organic compound to the ionic compounds. It means, for example, I wanted to identify whether the given compound contains a sulfur or any phosphorus or any halogens, then I can treat that with sodium in a fusion tube. Then I can break it out, so that whatever the compound we have, organic compound, whatever the nitrogen we have in that along with the carbon, converts into sodium cyanide, which is an ionic compound. Or if there is any halogen, with sodium fusion extract converts into sodium halides. All these are what? Ionic compounds only, no? Yeah. So a compound, organic compound is a covalent compound, converts from covalent form to ionic form. So this is the main thing that happens in the Lissagne's test. Okay, the next, number of hydrogen atoms present in 5.4 grams of urea. So what is the molar mass of urea? They only mentioned is as 60. Now you need to know the formula, molecular formula of urea. So how can you write this? C double bond O, NH2, NH2. So how many hydrogens are there in one molecule of urea? 4 hydrogens are there. Okay, so the next time you can expect how many nitrogen atoms are possible for this. Very simple now. Atomicity you take. How many hydrogens are there here? 4. That's it. So now what will be your answer? See, number of hydrogen atoms present in 54 grams. If they have mentioned 60 grams, we can say it is 1 mole of that substance. So first of all, find 54 grams means 5.4 grams means how many moles of urea. So the number of moles of urea you find by dividing given weight by its molar mass. Okay, that's it. This gives you number of moles of urea. In 1 mole urea, there will be Avogadro number of urea molecules. In 1 molecule, there are 4 hydrogen atoms. You can write it like this. Avogadro number, I can write it as 6.02, 6.02 into 10 power 23. Okay, and in 1 molecule of urea, how many hydrogens are there? 4 are there. That's it. Okay, so this is almost like 6 by 60. How many times it is? 10 times. The next thing, here you can remove 0 and write it as 22. Okay, finally what are the things we are remaining with? 5.4 into 4 into 10 power 22. So it will be 4 4 is 16, 1, 20, 21. So 0.1 in 10 power 22. Okay, just check for this kind of options. Yeah, if you check at these two options, you can able to identify it. So just check the final answers. Here we have either 1 or 2. Just check. We got 21.6 into 10 power 22. So I can write this as 2.16 into 10 power 23. So it means the best suitable answer here will be option number 1. Okay. And once again I want to say you and remind you one thing. Whenever you are solving something, see, you can get the final answer, but verifying the options properly is important thing. Even after giving this much of energy to the question, if you are not choosing the proper answer, everything will be went into the wastage, I can say. The next one here, 66th question, which are the following pairs are metamers? How can we identify metamers? Metamers are those isomers which are differing two alkyl groups attached to a particular functional group. For example, metamers, whenever we discuss about metamers, it is better to understand it with ethers. Like I am writing ether means like formula like ROR2 alkyl groups on the oxygen. So put ethyl group this side, CH3, CH2, CO, CH2, CH3. You can write it like this now. Okay. So with the same molecular formula, what I am doing is, one side I am placing methyl group and another side I am placing propyl, CH2, CH2, CH3. See how these 1 and 2 are related? They are differing the just alkyl groups attached to the functional, that is oxygen here. So 1 and 2 are called metamers. Okay, they should have same functional group, but the different alkyl groups attached to that functional group. That's it. Okay, yeah. So go with the options. So this is primary alcohol, secondary alcohol. No, not this one. Okay, next one. Here, this is methyl group, methoxy, there is a methyl group, another side is propyl, and here ethyl and ethyl. Whatever we discuss, that will be your answer here. Okay, that's it. Next here it is a ketone aldehyde. These are functional group isomers. Okay, very simple question this is. Okay, so option 2 will be a perfect for the discussion. Next 67, the incorrect statement from the following. So there are 4 statements, they are asking incorrect one. So how can you say? So this is related to anomalous behavior of second period elements like nitrogen, carbon, all this shows some anomalous behavior compared to the respective group elements now based on that. See, phosphorus, arsenic can form d pi bond with the transition metals, yes. Okay, nitrogen can form d pi p pi. See, nitrogen have only 2s and 2p orbitals only now. It means it can make only either sigma bonds, and it can also make pi bonds, but that should be something like p pi p pi. Okay, p pi, not like d pi, because there is no d orbital only. How it can make a d pi p pi bond? Okay, so it means perfectly option 2 you need to choose, because they are asking about incorrect statement. Next, nitrogen can show p pi multiple bonds. Yes, this is perfect. Next, phosphorus, arsenic, antimony shows catenation properties. Yes, they can show catenation property. Okay, only nitrogen cannot show catenation property in the 15th group. So what is your answer for the discussion? Second option. Next, yeah, phenolphthalein is used as an indicator for the titration of sodium hydroxide. What they are saying? Phenolphthalein is used as an indicator for the titration of sodium hydroxide, NaOH, against standard solution of oxalic acid. Okay, so the color change that is observed at alkaline pH. See, alkaline pH, first of all they are using phenolphthalein now. So phenolphthalein is a weak acid. What I am saying, phenolphthalein is a weak organic acid. So in acidic medium it is colorless. Please listen here once again, it is a colorless in acidic medium. Okay, so whenever you place this phenolphthalein in the basic medium, that is pH greater than 7 at 25 degrees, now that H plus ion get ionized, becomes pH minus. Okay, it means anion is formed, ionized, phenolphthalein get ionized here. So in the ionized form, phenolphthalein color will be pink. What is the color? Pink. A colorless substance converting into pink color. So this is what we will be looking at the end point of the titration. Okay, so now what they are saying, what is the color change observed at the alkaline pH? At the alkaline pH, if the pH is greater than 7, Alkaline pH they mentioned now. So alkaline pH definitely we are going to see as a colorless to pink color change. Okay. So where do we have colorless to pink? The third option is your perfect for the discussion. Okay. Next, this one, very simple question again based on hydrocarbons, like just identifying hybridization, number of sigma and pi bonds. See, C2H4 means every student who is taken chemistry as one of the subject might aware of the structures here they have mentioned. C2H2 means ethane. So now count number of sigma bonds, pi bonds in the given compound. That's it now. Methane. So methane contains all 4 sigma bonds only. So C3. Next, ethane means there should be 1, 2, 3. 3 pi bonds, 3 sigma bonds, 3 sigma bonds, 2 pi bonds. Okay. So 3 sigma bonds, 2 pi bonds. Ethene means 1, 2, 3, 4, 5. 5 sigma bonds, okay, and 1 pi bond. So A4. Like that you can match. NH3 means what we know, 3 sigma bonds with the hydrogen atoms, 1 lone pair. So D2, that's it. Based on that you can match the answer. Next, 70th question here. Based on first law of thermodynamics, that is what? Delta U is equals to delta Q plus dW, delta W. Okay, they mentioned it as during the process 500 joules of heat is absorbed by the system. So delta Q, how much energy is absorbed? 500. Absorbed means plus. Okay, then next, what they have mentioned? And work of 200 joules is done by the system. Done by the system now, so negative. Okay, that's it. So delta U. So it will be plus 300. So how much internal energy? So change in internal energy is 300 joules. So option 2 is your answer for the discussion. Methane react with steam at 1273 Kelvin in the presence of nickel catalyst. So here it will form carbon monoxide plus H2. This is what synthesis gas. At the end of the discussion, we might be, every teacher might cover this this portion, because hydrocarbons, particularly at alkenes, at the end of the chapter, this kind of reactions will be there, like aromatization, isomerization, and the next we will be coming up with this one, methane upon partial combustion. Partial combustion, here it is what? Heating in the presence of nickel catalyst gives you CO plus H2. So this combination is called a synthesis gas. Okay, syn gas or synthesis gas. Then next, here again from aldehydes, ketones, carboxylic acids. Again very simple this one. See, a compound, most of the students by looking at the question they feel scared and they will leave it. But this kind of questions are the deciding questions, rank deciding questions, I can say. Now see, a compound P gives a red orange precipitate with 2,4-DNP reagent, and it does not reduce a Fehling's reagent, and we know Fehling's reagent cannot be reduced as aromatic aldehydes, and even if there is a ketone, it cannot disturb or it cannot show any reaction with ketones or aromatic aldehydes. Okay, this is the story. Definitely from the given 4 options, it can be an aromatic aldehyde or a ketone. Okay, these are the 2 possibilities we have. On drastic oxidation with chromic oxide, we know chromic oxide is a strong oxidizing agent, easily oxidizes aldehydes to carboxylic acid. But in case of ketones only, we require drastic condition, like high temperatures are required. It means definitely the given compound might be a ketone. That's why they are saying, and drastic oxidation with chromic oxide, P gives an aromatic product Q. So chromic oxide under drastic condition converts ketones to carboxylic acid. That carboxylic acid produces effervescence on treating with bicarbonate, because carboxylic acids only will show the reaction with sodium bicarbonate. Okay, it means definitely they are asking about Q and P and Q now. So P definitely a ketone. So where do we have ketones? Only second option is having ketone and first option also having ketone. But they told only 8 carbons, already 6 over, 7th one, 8th one here. Okay, our product upon oxidation, what happens? Will be removing the CH3 group, like we'll call it as Popoff's rule, where ketone like methyl groups, smaller groups will be removed out and both of them converts into carboxylic acids. Now this carboxylic acid is this one. Okay, so what are the two products formed upon the Parfov's rules? I mean, treating with chromic oxide, we will get a benzoic acid as well as methanoic acid, you can say. Okay, this kind of products, but anyways in the option Q is there. So this benzoic acid treated with bicarbonate, yeah, effervescence we will be seeing of due to the reason that CO2 gas will be evolved there. That's it. Next here, just try this electrochemistry question, everyone in the comment box will be looking into it. So just try this question, 73rd question here. Yeah, I can simply say this as, see, a solution of copper sulfate is electrolyzed for 10 minutes with a current of 1.5 amperes. The mass of copper deposited at the cathode, this is from where? Faraday's electrolysis, right now, first law of Faraday. So what it says? Quantity of a substance, the amount of substance deposited directly proportional to the quantity of charge passed through the electrolytic solution. So the weight will be now equals to Z into I into T. So what is this Z electrochemical equivalent? That is E by F into I into T. Okay, what is mean by E? It's equivalent weight. What do we mean by equivalent weight? 6 copper plus 2 converting into copper now. So how many electrons are involved? 2 electrons. So divide its molecular weight, that is 63 by its n factor, that is 2. Okay, and Faraday value we know 96500. Okay, into I value is how much given? 1.5, and time is given as 10 minutes, convert into seconds. So 10 into 60. Okay, now just simplify this. Just simplify this, you are going to get option 1 as your answer for the discussion. Okay, the next, the functional group that can be identified through Thalline dye test. So what do we mean by Thalline dye test? See here, it will be something like this. Phthalic anhydride will be there. So this phthalic anhydride treated with one of the following that gives you a color change. Okay, so generally this Thalline dye test is used for phenol identification. Why? Because phenol, 2 molecules of phenol react with 1 molecule of phthalene and forms phenolphthalein. What it will be forming? Phenolphthalein. So that is what the test is used for. So phenolic groups can be used here, I mean identified here. So how the reaction takes place means, see, we know phenol activates the ring at para position now. So the minus charge is created here. So this nucleophilic center attacks at this electrophilic center. So like that, this complete O will be removed. So 2 phenol rings will be adjusted over here. So that is nothing but our phenol ring. Okay, phenolphthalein. That phenolphthalein indicator we will use now, that is the structure. Okay, now one question about DNA, once read this. The correct statement with regard to the secondary structure of DNA and RNA. DNA possesses a single structure? No. Single stranded? No. Next, it contains uracil? No. Next, here next statements if you go, RNA possesses single structure stranded helix and contains thymine. So what are the things we have present in DNA? So it will be like AT, GC, right? And in RNA it will be AU, GC. Based on this you can solve the question. Okay, so DNA possesses double strand helix and contains thymine like T here, no? So that's it. First you can go with the third option, that's it. Okay, next you can verify 76th question. So this kind of questions will consume your time during the exam because they are asking us to verify this. See, they mentioned molality of 2.5 grams of ethanoic acid and by giving the data. So you need to take molality formula and substitute the values and verify this. Then only you can able to answer this because they have given like this, AB is correct, BC is correct, something like this. Okay, and the second option also they are asking us to verify that molarity of the solution is given as 0.278, whether it is correct or not, we need to verify that. Okay, anyways, we will solve this in a simple manner. Go with the option C. Aqueous species are more comfortable cold water, yes, I can agree with this, because in cold water there will be more dissolved oxygen, so they can survive in a better way when we compare with the normal water, right now. So this is perfectly correct. Next one, solubility of a gas increases with a decrease in pressure. No. So a gas can be solubilized in the water when we apply more amount of pressure on it. That is what we study it as Henry's law, right now. So this statement is incorrect. Okay. Next, the binary mixture of AB, a mixture is formed from A and B. The number of moles of A is given as Na and number of moles of B is given as Nb. Then mole fraction of B should be, the mole fraction of B should be like Nb by Na plus Nb. So it should be like this, but they told it as Na. This is also incorrect. So what are the things I have verified? Only C, D, E I have verified, and there should not be any C, there should not be any D and E. So D and E should not be there. Okay. So now C should be there, because C is perfectly correct now. So in this C is not there, in this C is there. Okay. And I need to verify B, because B is here and here it is not there. So just verify B, whether the statement is correct or not. The molarity of solution containing, molarity, solution containing, moles, how many grams of solute is given? 5 grams. Molar mass is 40. And how much volume mentioned? 450. And it is having 1000. That's it. Okay, 0, 0, 0, 0 removed. Next, 5 9s. Okay, so finally how much we are going to get? This will be 2.5 divided by 9. So 2.5 divided by 9 means 25 by 9 I can write, and it can be 327. 2s, it can be 2s and 7, 8. Okay, this is almost correct only now. So B is also should be there. So I can go with A, B, C as my second option as an answer for the discussion. Okay, so this is how you can solve them in the simple manner possible without taking too much of time for each and every question. Yeah, next. Yeah, when I discussed about chloroform, I mean Raoult's law, definitely I will give this example and with a proper explanation. So they mentioned chloroform with acetone. What type of deviation it shows? A negative deviation. They mentioned it. Okay. So why the negative deviation is showing? Because chloroform and acetone, between these two molecules there is intermolecular hydrogen bonding that makes them to come closer to each other, therefore it forms a negatively deviated solution. Okay. So where do we have formation of hydrogen bonding between acetone and chloroform is a reason for the discussion right now. Yeah. So all other questions statements are not correct. Next. So this is a buffer solution question. Read it. A certain buffer solution contains equal concentration of its ion and HX. See, HX is dissociating to give some kind of ions like H, maybe H plus and X minus. They have mentioned Kb value as 10 power minus 10. So if they are mentioned Kb value, so I can calculate Pkb, I can calculate Pkb here directly. Pkb becomes 10. Okay. Next, from this I am considering this, since Pkb is given, I will be taking this as POH formula, or you can consider Pkb plus pKa is equals to 14. So from this pKa will be equals to this Pkb value is 10 now, 14 minus 10, that will be 4. Okay. So that's it. So anyways the given buffer might be acidic buffer, so it can be taken as pH equals to pKa plus log concentration of that ion by like salt by acid or base we will be taking. Okay, that's it. So you can take that two things over here. They are saying concentrations are equal. These two concentrations are equal. So this term becomes 0 because log 1 is 0 now. That's it. Now pH equals to pKa will be your answer. So what is the pKa value we got? 4. So it means option 3 is your answer for the discussion. Next. What about the statement? Identify the incorrect statement from the 4 options. Okay. So septium they are saying. Okay. Next. Okay, they have mentioned. Okay, single answer only na, easy. The largest and smallest species among magnesium and magnesium plus 2 and aluminum plus 3. So the largest will be like magnesium, aluminum, definitely magnesium. magnesium plus 2, aluminium plus 3, okay, and here it should be like this. So the largest and smallest species among the ions are aluminium. The largest aluminium they are saying, no, largest will be magnesium, because if you go from left to right in the periodic table, what happens to the size? Decreases, right now. So magnesium should be larger size, okay. So it means second option is incorrect. They are also asking about incorrect statement. Definitely second option will be incorrect. Next, you can verify other statement. The similarity in behavior between lithium and magnesium is referred as diagonal relationship. Perfect now? Yes. Next, oxidation state of aluminium, yeah, that is also perfect. Coordination number is also 6, yeah. Next, increasing metallic character. What happens from left to right? Metallic character decreases. P block elements are generally non-metals. These are metals, we'll say now. So sodium should be highest metallic. The next, magnesium. Okay, magnesium, and least one is phosphorus. Least one is phosphorus here. So go with the first option. That's it. Okay, that's it. Next, IUPAC nomenclature. Yeah, go with this. How can we start this? If I start from here, 1, 2, 3, 4, 5, 6, 7. So 7 we got here, 3, 4, 5. Okay. If I start from here, 1, 2, 3, 4, 5. So anyways, both sides it is giving substituents positions as 3, 5 only now. So from any of the side you can go. Okay. But this is ethyl group, this is methyl group now. Follow alphabetical order now. So ethyl, small, like this E alphabet starts first now. So give it a minimum number. So it will be 3, this will be 5. Okay. So it means 3 ethyl 5 methyl heptane will be your answer for the discussion. Okay. Next, 82 question here. Very simple. Match the complex with the structure. How can you match this? Look at this. Platinum, all platinum tetra coordinated complexes are square planar. Directly you can remember. So A3. Next, cobalt hexamine. So this complex I usually discuss this every time in the class. Mostly I will take cobalt hexa coordinated complexes only. So this will be having octahedral geometry. So nickel tetra coordinated complex directly from the class. Okay, C 4 coordination number means it will be tetrahedral with weak field ligand. Okay, and here iron with 5 coordination number forms trigonal bipyramidal. That's it. Based on that you can match the option. Next, here for a certain reaction, the plot concentration of reactant versus time is given with a negative slope. The order of the reaction will be, see, it will be a zero order reaction. Why zero order reaction? The differential equation, if you consider dA by dt, change in concentration of A with respect to time will be what? Rate. So the rate of equation will be equals to k naught to the power a naught. So something power 0 will be 1. So I can write minus dA equals to dt. Okay, I am using the integration here. Initial concentration as R naught, final concentration RT, initial time as 0, final time as T. Okay, now what happens to the equation? So upon simplifying this, RT minus R naught with a minus symbol here gives you T minus 0, that is T only, and here K naught as it is constant, K naught as it is constant. Now they are asking concentration versus time now. So I want RT. So for that I can write RT will be equals to R naught minus K naught T. This is your final output you will get upon simplifying. So draw the graph now. RT here, T here. So this is y equals to minus m x plus c type of graph. Like this you will get. So that's why we are saying it as a zero order graph. Okay. Chemical kinetics is incomplete without knowing the graphs. Okay, next. Which of the following is ambidentate ligand? Yeah, clearly discussed about ligands, classification of ligands. Ethylene diamine tetraacetate, this is a hexadentate ligand, polydentate or hexadentate ligand. Oxalate is a bidentate ligand. Ethylene diamine is a neutral bidentate ligand with NN donor. This is OVO donor. Okay, and thiocyanate, SCN, is what? Ambidentate. It can bind from sulfur or it can bind from nitrogen also. So I can say it is a ambidentate ligand. Then next here, delta U is given, delta G S is also given. They are asking delta G naught. So first, in order to find delta G naught, you need to have delta H naught value and T delta S naught. Okay, so they mentioned temperature also. So from here, delta U, you can get this delta H. So delta H is equals to delta U plus delta Ng RT. So how many moles of gaseous reactants products are there? 2 minus 3, because 2 plus 1, 3. So 2 minus 3 will be minus 1 RT. So this is delta U minus RT gives you delta H, right now. So delta U is how much mentioned? It is minus 10 kilojoules is mentioned. Minus R value how much mentioned here? 8.3 into temperature 8.3 joules, but we want in kilojoules. So 10 power minus 3 into 298 we have. So 298. So upon simplifying this, you will get 0.3 around roughly. So 10 kilojoules minus this will be minus 8.3, like you can write this as it is, minus 10 minus of 8.3 into 0.3. So 3 3 is a 9, 9 3 is a 24. So I can simply write it as a 25. Okay, and how many decimals are there? 1 2. So 0.25. So it will be the scenario now. So it will be around minus how much we got? Delta that thing. Okay. Okay, it is minus 10.25 we got. Okay, like this we got now. Delta H value we got. So delta H is negative. Now T, what about delta S? Delta S is also negative. So negative into positive, it becomes a positive value. Second term becoming positive. So in order to make a spontaneous process, delta G naught must be negative. In order to make this negative, first term has to dominate. So what to check here? Delta H naught by delta S value should be greater than T, then only we can say the process is spontaneous. Okay, process is spontaneous. Now what to check? You take this value over here, divide that with this value. If the value will be greater than T, then your answer will be the one of these options. Okay, so anyways, if you calculate, you will get this second option here. So yeah, I just want to wind up this with the last 5 questions are there. You can simplify this and tell me if you have any confusion. I will discuss that once again. Next, Fazan's rule. I mean, what is this? Formal charge. What is the formal charge formula we have? Formal charge is equals to, okay, valency electrons of that central atom, that atom which we are considering, minus number of non-bonding electrons place half into number of bonding electrons. That's it. Even in the crash course, I have given the same example. Okay, so right. So let us do it for this third one. So how many valence electrons are there in the oxygen in its atomic state? 6. No, number of non-bonding electrons, 6 dots are there means 6. Place half into number of bonding. 1 bond means 2. Okay, these two get cancelled. So it is 6 minus 7, that is minus 1. So for this oxygen, it will be minus 1. This will be plus 1. Here it will be 0. So based on that, you can match the option. So first of atom 1 should be plus 1, 2 should be 0, 3 should be minus 1. Based on that, you can check. So delta Ng, I mean here again 87 Kp Kc relation, very simple now. Without this, we cannot even start equilibrium chapter. So what is that? Kp equals to Kc into RT power delta Ng. So delta Ng value you check here. So they should not be equal, they are saying. Delta Ng means gaseous products minus reactant, 1 1. So 2 minus 2 0. So delta Ng is 0 here. This term is 0 now. This complete term become 1. Something power 0 is 1 now. So Kp Kc real equal here. They are saying not equal. So in this case 2 minus 2, here also 0, they are equal here. So here 2 minus 4, that is minus 2 now. Here it is not equal. Kp equals to Kc into RT power 10 power minus RT power minus 2, you will get the answer. So option 3 is a perfect answer. Next here 1 1. So 2 product side, 1 1. 2 reactant side, all of them are gaseous. So 0. So 1 2 4 are having delta Ng as 0. So it means the Kp Kc are equal. Only option 3. This is the most commonly asked question from equilibrium chapter that everyone can answer. Okay. Next, given 88 from Arrhenius equation. Look at the expression they have given. So this is how they have mentioned. What is the formula we have? ln k is equals to ln A minus EA by R into 1 by T. How we got this equation? K is equals to A e to the power minus EA by RT. This is the Arrhenius equation now. So just send this A here, K by A it becomes. Exponential term this side, ln of K by A it becomes, which is equals to minus EA by RT. So that is what here I have written. Ln K by A means ln A, ln K minus ln A I can write, I can finally make it like this. So finally they are asking us to calculate activation energy in kilocalorie they are asking. So now if you compare the given equation with our standard equation, ln K as it is. The first term is nothing but ln A. The second term is this one, T is there now, 1 by T as it is. So minus EA by R will be equals to 1.25 minus 1.25 into 10 power 4. That's it. That's it. You got your final answer. Check here. Minus EA, minus minus can be removed. So finally you have EA is equals to 1.25 into 10 power 4 into R. What is the R value they have mentioned? They want answer in terms of kilocalories. So R is 1.987 calories. Kilocalories means 10 power minus 3 kilocalorie per Kelvin per mole you can write. Okay. So this can be cancelled. We are having 10 as a thing. So this is nearly 2 now. So nearly 2 means you are going to get 2.5 into 10 kilocalories, that is around 25 kilocalories. Okay. So here you have 24.84, that is your answer, because 25 we approximated, only one option we have like that. Next, last two questions we have. Yeah, let us finish this. So ethyl chloride treated with X forming Z. Okay. Next, amide treating with bromine and NaOH. This is Hoffman bromide. Every year there is at least one question related to Hoffman bromide degradation. Okay, every year there will be one question related to Hoffman bromide degradation. So now look at this. Amides upon treating with Br2 NaOH gives you ethyl amine. Okay, this is your Y. Y is treated with chloroform and ethanolic acid. So this is what? Primary amines with chloroform in basic medium gives carbyl amine test. Even in the shorts also I have covered this same story. So definitely here it will be ethyl isocyanide. So what is this? Ethyl isocyanide. So we got here Z and we have got here Y also. They are asking us identify X, Z in the given compounds. So in order to get this Z, ethyl isocyanide. So ethyl isocyanide, where are the options we have? Z, ethyl isocyanide. So in order to get this Z, what I can use so that ethyl chloride converts into ethyl isocyanide. So if I use KCN, what happens, you know? K plus Cl minus, Cn minus. So here it's an ionic compound now. So carbon is a nucleophilic site, replaces chlorine. But if I use AgCN, this is a covalent compound. The bond breakage won't take place between silver and carbon. Therefore, the nucleophilic center here in the compound is nitrogen. Therefore, it gives you isocyanide. So, ethyl isocyanide comes from ethyl chloride by treating it with AgCN. Okay. So, I hope this is also clear. So, what is the mechanism involved there? Nucleophilic substitution. Now, in the similar way, I am making a question for you here. Ethyl chloride upon treating with NaNO2, what will be the product here? I am saying it as A. And upon treating with AgONO, what will be the product here? B. So mention AB in the option. Okay. For our discussion for this, fourth option is perfect. You just mention what is your answer for these two in the comment box. Next, one last question for the discussion. Yeah, look at this. Platinum tetra-coordinated complex is there. What type of geometry or isomerism it will show? All platinum tetra-coordinated complexes are square planar, I told you, and here it is of MA2B2 type. So cis-trans isomerism is possible because it is a square planar. So geometrical isomerism you can go with. Okay, and here cobalt. Again, even this discussion is also I have clearly mentioned, and I did 2 times the same story about isomerism even for crash course series and also NEET long term. They might remind these things in the exam also, I think so. So here it is given as metal and in tries. plus 3. So how it is in tries now? So it will show us optical isomerism B1. Okay. Then next here, solvate isomerism is possible when we interchange water molecules inside outside. So D2. Next, this one is linkage isomerism. Whenever we have something like ambidentate ligands, in linkage isomerism is possible. Okay. So C4. Based on that, so A3, B1, C4, D2. So our perfect answer for the discussion is 3. I hope every question here we discussed in the session will be are covered in our discussion of last 1 year long term program, as well as whatever the courses we are conducting, like crash course or any other course. Okay. Now if you have any confusions, you please write in the comment box. We will be discussing them in the upcoming sessions. And if you wanted to reach us regarding any guidance for upcoming batches, you can reach us with the mobile number provided in the description box. So thanks for watching. Stay connected with NEET World. Thank you.